Hi guys, it's Mrs. Allen here. Tonight we're looking at 2.5 AP Calculus AB, Notes, Practice, and Test Prep. We're going to be taking the derivatives of cosine, sine, e to the x, and ln of x. So you've got several rules already where you have the power rule, the product rule, and the quotient rule. And so we're going to introduce derivatives of cosine and sine first. So the derivative of cosine you see in the box is negative sine x, and the derivative of sine x is cosine x. Now I'm just going to give you those, so you just kind of have to use the rule for this lesson, but we're going to be looking at the graphs and kind of examining the graphs of sine and cosine in class. So the first thing we have is find f prime if f of x is equal to 2 sine x minus 5 times cosine x. And you see that underneath I've got f prime of x is equal to 2 times the derivative of sine x minus 5 times the derivative of cosine x. So recall that we can pass a constant through a derivative. So we get f prime of x is equal to 2 times cosine x. The derivative of sine x is cosine x. And then we have minus 5 times, then we have the derivative of cosine is negative sine x. So instead of doing another line, I'll tell you what I'm going to do. I'm going to just make that then plus sine x. Plus 5 times 5, plus 5 sine x. So because that was negative sine x for the derivative of cosine, so minus 5 times negative sine x is plus 5. Okay, there you have it. And then, so in the next section, what we're going to do is we're going to talk about the natural log and powers of, not powers, but exponential functions. So we have ln of 1, recall, is 0. ln of 0 does not exist, right? Does not exist. Actually, it's negative infinity, but we'll talk about that then. E to the 0 is 1. E to the ln of a is a. And ln of e to the a is a. And it's because e and ln, they're inverse operations. E to the power of x. So derivatives of exponential functions, and for right now, we'll accept this rule. We'll talk about it more and how we can derive it so you understand that. So the derivative of a to the x is a to the x ln of a. And the derivative of e to the x is just e to the x. It's what I call the superpower derivative. So underneath we have finding f prime if f of x is equal to 2 to the x plus 3 e to the x. So we've got f prime then is equal to, f prime of x is equal to, we're going to have a 2 to the x times ln of 2. A is, in this case, 2. And then plus 3 times the derivative of e to the x is just 3e to the x. And there we have that. Okay. So then the next derivatives we have are the derivative of log base a. So a can be any base. So the derivative of log base a of x is 1 over x ln of a, written just like that. And most of the time, you can see how I put parentheses around the previous derivative. I very often put parentheses around that ln of a just to stipulate it as a separate factor. Then the derivative of ln of x is equal to the derivative with respect to x of log base e of x. So I really could put, I'm going to sneak this in here for a second. The base is e, so you can see that I could write it like that. But ln of e is equal to 1. So most of the time we just leave that out and say 1 over x is the derivative of ln of x. Okay, so here's our first example here. We have f prime if f of x is equal to log base 4. So when we take that, we're going to use the first rule over there, and it's going to be f prime of x is equal to 1 over x times ln of 4. And then it'll be minus 4 times 1 over x, which we can write as 4 over x. And there you have it. Okay, find the derivative of each function here. So you can see that I've put the derivative operator in all of these and passed the constant out through. So I have f prime of x is equal to 2 times the derivative of sine x, which is cosine x, plus 5 times the derivative of e to the x, which is just 5 e to the x. And there you have it. Okay. So the second one, I have the derivative f of x is equal to 3 to the x minus 4 cosine x. So you can see I have f prime is equal to the derivative of 3 to the x minus 4 times the derivative of cosine x. So I get f prime of x is equal to 3 to the x times ln of 3 minus 4 times the derivative of cosine, which is negative sine. And I'm just going to take an extra step on this one. And I'm going to say that I would end up with 3 to the x ln of 3. And that would be plus 4 sine x. And there would be my derivative. Then for the last one, we have f of x is equal to log base 2. So a is 2 for this one. So the logarithm, I have f prime of x, the derivative of log base 2 would then be equal to 1 over x times ln of 2 minus the derivative of sine x, which is cosine x. Okay, now we can always take a little bit of time to manipulate things, but that would be our final answer. We could get a common denominator if we wanted to. Okay, we have two more. Find the value of the derivative at the given point. So for number 4, I have f of x is equal to 3 ln of x plus e to the x. And in the end, I want to find f prime of 5. So you can see I laid the derivative out in the first step. F prime is equal to 3 times the derivative of ln of x plus d dx, the derivative of, let me put this here, of e to the x. Now, in the end, our answer is going to be the derivative evaluated at 5. As you can see, I have that down here. So we've got f prime of x is equal to 3 over x plus e to the x. So we end up with f prime of 5 by substituting in 3 over 5 for x plus e to the 5th power. And that would be our answer. Now, we could round if we wanted to, but that would be the value of the derivative. Now, remember that e is approximately 2.71, 8 to 8, but who's counting? Okay, so we have our answer there. For the second example, 5, we have f of x is 3 cosine x plus sine x over 2, and we want to find f prime of pi. So in this case, we have f prime is equal to 3 times the derivative of cosine x plus 1/2 times the derivative of sine x. So we take the derivative and we get negative 3 sine x plus 1/2 cosine x. So to get f prime of pi, we simply replace x with pi plus 1/2 times cosine pi. So our trig function values at that time, f prime of pi, then would be negative 3 times 0 plus 1/2 times negative 1. And so we end up with 0 minus 1/2. So our final answer then, f prime of pi, is a value, and that is negative 1/2. Okay, so that's our video for tonight. I think I've been trying to stay away from boxing quantities or answers up because I know that that's something that you want to practice for the AP exam. But moving forward, you have some practice problems. So you can see you have these. So moving forward, getting the practice in with them. And then come down here, you have some test prep problems. That would be the type of problems that you could expect on an AP exam. Okay, you can see that setup here is looking like limits that you've dealt with before. So what I would do is, if you're looking at this closely, see if you can determine what is the function. In the case where there's an a value, what is a? And what is f of a? Can you recognize what the limit is? And then try to figure out what this is, and then say, oh, well, that's just f prime of some value. F prime of a, right, when you're looking at this. So try to work through those. Okay, that's it for tonight, and I'll see you when I see you. I'm going to post this, and you may not receive it tonight, but it's a pretty quick little lesson. And then tomorrow we'll work on the tangent and the cotangent and the secant and the cosecant, and just moving forward with section 2.5. So listen, you guys have a great night, and I'll see you when I'll see ya. Alanator out.